Hi everyone, this is Mrs. GA and today we're going to be modeling with expressions. So here's a quick warm-up. Try to solve the two equations below and then we'll check your answers in just a few seconds. Alright, go ahead and check your answers here. So remember, one thing we talked about in a previous lesson is when you have an equation with fractions like this, if you multiply both sides by the least common denominator, it will make your fractions disappear. So the LCD of 3 and 5 is 15. So look what happens. 15 divided by 3 is 5 times 4 is 20. No more fraction. 15 divided by 5 is 3, so 3x, and then 15 times -2, and it makes the equation much easier to solve. So that's how I would recommend solving any equation with fractions. And then in part B, you'll notice that we have a variable on both sides. So you pick the smaller one. The smaller one is actually -5x because it's negative, and then we can move it by adding 5x to both sides. And then from here, just finish solving for x. All right, so some vocabulary that you're going to hear in today's lesson. First is an expression. So an expression is a mathematical phrase that contains operations such as plus, minus, multiply, divide, numbers and or variables, but no equal sign. So that's the big difference between an expression and an equation. A numerical expression is an expression with numbers only, and an algebraic expression is an expression that contains at least one variable. Terms are the parts of an expression that are being added together, and a coefficient is the numerical factor that's in front of each variable term. So we're going to start by practicing identifying these different things. So let's look at this expression. 2x plus 3y minus 4z minus 10. So first we're going to identify the terms. So remember, the terms are the parts that are being added together. So if it helps you, you can actually rewrite it like this: 2x plus 3y, because maybe you're thinking, well, this one's not being added, it's being subtracted. But we can actually rewrite it like this: plus negative 4z, and then we can even say plus negative 10. So our terms are going to be 2x, that's one term, 3y, negative 4z, and negative 10. So notice that the negatives are part of the terms. And then we could also list out the coefficients. So remember, the coefficient is the numerical factor that's in front of a variable. So the coefficient of x is 2, so we have a coefficient of 2. The coefficient of y is 3, and the coefficient of z is negative 4. And since this last term doesn't have a variable, it does not have a coefficient. Okay, so now we're going to be looking at algebraic expressions in context to some type of real-world situation, and we're going to see if we can interpret the different parts of the expression. So this says, Katie is buying school supplies. She purchases P pencils for 75 cents per pencil and H highlighters for $1.45 per highlighter. So notice here, we don't know how many pencils she purchased, so we gave it a variable P, and same for highlighters, the variable is H. But it does represent some number. Interpret the meaning of the expression 0.75 P plus 1.45 H. So let's see if we can break apart the two terms, and then we'll look at it as a whole. So I'm going to write it a little bit bigger here. So the first thing you see is 0.75 times P. So if 0.75 is the price per pencil and P is the number of pencils she bought, if you multiply those together, this would be the cost of all of the pencils. Right, that's how you calculate a total cost. You say, what is the cost per item and how many items did you buy? Now, over here, you see that we have $1.45 or 1.45, which is the price per highlighter, times H, which is the number of highlighters. So this term must represent the cost of all the highlighters. So if we're taking those two things and we're adding it together, then this expression as a whole must represent the total cost when Katie is buying school supplies. Okay, let's try one more together. Laurent is buying white paper and green paper for his business. He buys 8 more packages of white paper than the G packages of green paper. White paper costs $5 per package, and green package costs $6.75 per package. Interpret the expression 6.75 G plus 5 times G plus 8. So again, let's see if we can break apart the different terms and then look at the expression as a whole. Okay, so here 6.75 is the cost per package of green paper. Let me highlight that in green. And it says that he buys G packages of green paper. So if you have the cost per package times the number of packages, this must be the cost of all the green paper. Okay, now let's look at this next part. So this next part has the 5, which is the cost of the white paper package. And then it says G plus 8. So here it says that Laurent buys 8 more packages of white than green. So if green is G packages, if you add 8, that gives you 8 more. So this little portion right here, G plus 8, actually represents the number of white paper packages he buys. So if you take the number of white paper packages and you multiply it by the cost per package, that should give you the total cost of white paper. So this first term represents the cost of all of the green paper. This second term represents the cost of all of the white paper. So since we're adding those up, this must represent the total cost of paper. All right, at this point, I'm going to ask you to pause the video and see if you can give this problem a try, and we will check your answer in just a few seconds. Okay, let's have a look. So here, this first one, 4.5 is the cost for a watermelon. W is the number of watermelons, so if you multiply, that must be the total cost of all the watermelon. 3.85 is the cost for one pineapple. And then W minus 3, this should represent the number of pineapples that were bought. The reason why we know that is because it says that she buys 3 fewer pineapples than watermelons. So you take W, number of watermelons, and you subtract 3. So if you add up those two things, that should give you the total cost of all of the fruit. All right, so now we're going to work with comparing algebraic expressions. So in example 3, we're given that the value x is larger than the value y. We're going to see if we can compare the two expressions and determine in some way which one is greater. So I want to know, is x plus y bigger than 2x? So let's think of it like this. X plus y we can leave as x plus y. We know that 2x simply means x plus x, right? So if you compare these two things, the two x's on each side, well, they're equal, so these could essentially cancel out. And then what we have left is a y on the left and an x on the right. So we know from the prompt that x is greater than y. So that means that the right side of our equation is bigger than the left side. Again, because x is bigger than y. So we can write the statement that x plus y is less than 2x. Okay, now let's look at part B. Here we have x over y, and here we have y over x. So let's really quick think about fractions. So if you have a fraction where the numerator is larger than the denominator, again, x is bigger than y. Let's just give an example. An example where the numerator is bigger than the denominator could be 3 over 2, right? So anytime the numerator is bigger than the denominator, your number is going to be greater than 1. Now let's look at this next one. In the second fraction, we have a numerator that is smaller than the denominator. So let's look at a real example of this. What if we did 2 over 3? Anytime the numerator is smaller than the denominator, we're going to have a number that is less than 1. So although we don't know what x and y are, we know that whenever the numerator is bigger than the denominator, it should always be bigger than when the numerator is smaller than the denominator. All right, so the last thing we're going to do in today's lesson is we're going to practice translating word problems into algebraic expressions. So here I have a list of some key words to look for that would tell you which operation to use in your expression. So anytime you see the words the sum of, added to, more than, increased by, totaled, altogether, even and, that should tell you to use addition. Anytime you see the words less than, minus, the difference of, take away, reduced by, or even fewer, you should use subtraction as your operation. Anytime you see times, here's one that's really specific to multiplication. The product of, a percent of tells you to multiply, per or each. Again, those are all keywords that could tell you to use multiplication. And then last, if you see divided by, the quotient of, the ratio of, that should tell you to use division. So we're going to be looking for different keywords that tell us how to set up our algebraic expression. All right, so let's give 2 a try together. So here we are writing an algebraic expression that models each situation. The price of an item, which is P, plus 6% sales tax. Okay, so we know we can start with just saying the price of the item, P, that part is easy enough. And then we see the word plus. Okay, so I'm going to put a plus sign. So now we have to find a way to represent this 6% sales tax. Okay, so anytime you're doing a percent of a value, what you need to do is you need to multiply the decimal version of the percent times the total value. So let's talk about how to change 6% into a decimal. So you're going to start by writing your 6. Right now it's 6.0%. And we're always going to move our decimal point 2 digits to the left. And anywhere we need to, we're going to add a 0. So 6% as a decimal is 0.06. And then to calculate the percentage, we do the decimal times the total. So we actually do 0.06 times P. So this term tells you what 6% of the price is. So we have the original price plus 6% of that price. And then since those are both terms with P, we can actually combine like terms and write it as 1.06P, right? Because this is 1P and then plus 0.06P. So using percentages, this is going to be a really common thing you do. So just make sure You change the percent to a decimal, and then you multiply it by the total value. That's how you find a percent of something. Okay, let's look at part B. The number of gallons of water in a tank that already has 300 gallons in it after being filled at a rate of 35 gallons for m minutes. Okay, so let's see if we can find a way to represent how much water is in this tank. First, it says it already has 300 gallons. So that's our starting point. So we can actually write that down. So that amount of water is in the tank. And then it's being filled up by a rate of 35 gallons for m minutes. So the amount of water that's added will depend on how many minutes has gone by. So we can figure out how much has been added by taking 35 and multiplying it by the number of minutes. So we're going to add 35 times m. And this will be our expression. Again, this was how much we started with, and then we're filling it up. So we're adding 35 gallons times however many minutes we're filling it up, which we don't know, but we have a variable to represent it. All right, here's the last problem for today's video. Please pause the video and give this one a try on your own, and we'll check in just a few seconds. Okay, let's start with part A, the price of a car, so C, plus 8.5% sales tax. So here's 8.5. Remember, we moved the decimal point 2 spaces to the left, so the decimal version is 0.085. So you have 0.085 times C. That's 8.5% of the total cost. So then the two you can add together, and it should give you 1.085C. The second one, the original price, P, reduced by, telling you to subtract, a discount of 15%. So we need to know 15% of the original price. So here's how you change the percentage to a decimal. So we would do 0.15 times P. That's how much the discount was. So if you do 1P minus 0.15p, it leaves you with 0.85p. Okay, that is all for today's video. Thank you so much for watching.